So here we have a question investigating the motor effect. It says figure 2 shows an electric motor. Draw an arrow on figure 2 to show the direction of the force acting on the wire AB. So we can see the wire AB has a current going from A to B. So we need to use Fleming's left-hand rule and then rotate our fingers to show us the direction of force, which is our thumb. So A to B is going, let's say, into the page, so point it in front of yourselves. So that's my middle finger here. You can then see the magnetic field is going from north to south on the permanent magnet. So that is left to right. So my index finger is going from left to right. So I can just look at my thumb, which is pointing downwards. So all I'm going to do here in the diagram is draw an arrow vertically downwards from AB. That's our first mark. Now it says suggest 2 changes that would increase the force acting on the wire AB. Now, if we want to increase the force, the 2 things that are affecting it, we just need to think about the left-hand rule. Force is your thumb. The 2 things that are going to affect it, magnetic field, your first finger, and current, your second finger. And you want to increase both of those. So the first one I'm going to say, increase the magnetic field strength and increase the current. Now it says suggest 2 changes that would reverse the direction of the force acting on the wire AB. So again, if you're trying to reverse the force, you need to think about the 2 factors, which are our same 2, the magnetic field and the current. So for our first mark, if we want to reverse the magnetic field, we can simply reverse the poles of the magnet, so south on the left and north on the right. And then our other mark, we can say we can reverse the direction of the current or swap around the direction of the batteries. And there we are, a question looking at factors affecting the force in the motor effect.